Hi, I am Mary Ann. Today we're going to talk about one important topic in algebra, the sequence. What is this sequence? When we hear about sequence, one thing you should come to your mind, a list of numbers written in a defined order. It's either ascending or descending. Example, 1, 2, 3, 4, 5, 6, 7 for ascending order and 7, 6, 5, 4, 3, 2, 1 for descending order. So there is an order. Sequence is a function whose domain is a set of consecutive positive integers. It is represented by a lowercase variable a, k, n, or I instead of x. It is called the terms in the sequence. Sequences are often given by stating their general or end terms. Sometimes it is referred to as progression. We have two kinds of sequence. We have the finite sequence and the infinite sequence. Okay, let's talk about the finite sequence or the finite sequence. Finite sequence can determine the number of sequence. It has a limit. Example, 10, 8, 6, 4, 2, 0, negative 2. Negative 25, negative 20, negative 15, negative 10, negative 5, 0. 3, 2, 1, 0, negative 1, negative 2, negative 3. 10, 8, 6, 4, 2, 0, negative 2 is a finite sequence with 7 terms. Negative 25, negative 20, negative 15, negative 10, negative 5, 0 is a finite sequence with 6 terms. 3, 2, 1, 0, negative 1, negative 2, negative 3 is a finite sequence with 7 terms. On the other hand, infinite sequence cannot determine the last number because there is a distinction indicated by the ellipses at the end of the sequence. Examples, 10, 8, 6, 4, 2, 0, negative 2, ellipses, negative 25, negative 20, negative 15, negative 10, negative 5, 0, ellipses, 3, 2, 1, 0, negative 1, negative 2, negative 3, ellipses, 10, 8, 6, 4, 2, 0, negative 2 is an infinite sequence with an infinite number of terms. Negative 25, negative 20, negative 15, negative 10, negative 5, 0, ellipses is an infinite sequence with an infinite number of terms. 3, 2, 1, 0, negative 1, negative 2, negative 3, ellipses is an infinite sequence with an infinite number of terms. Let's have another example. Find the range of values of the sequence given by a sub n is equal to 3n minus 1 for the domain 1, 2, 3, 4, 5. In order for us to solve this, let's assign the value of n which is equal to 1. So a sub 1 is equal to 3 times 1 minus 1 which is equal to 2. For n is equal to 2, a sub 2 is equal to 3 times 2 minus 1 is equal to 5. For n is equal to 3, a sub 3 is equal to 3 times 3 minus 1 is equal to 8. For n is equal to 4, a sub 4 is equal to 3 times 4 minus 1 is equal to 11. For n is equal to 5, a sub 5 is equal to 3 times 5 minus 1 is equal to 14. So the finite sequence are 2, 5, 8, 11, and 14. Another example is find the range of values of the sequence given by a sub n is equal to 2 raised to 3n for the domain 1, 2, 3, 4, 5. To solve this problem, let's assign the value of n which is equal to 1. So a sub 1 is equal to 2 raised to 3n which is 3 times 1 which is equal to 8. For n is equal to 2, a sub 2 is equal to 2 raised to 3 times 2 is equal to 64. For n is equal to 3, a sub 3 is equal to 2 raised to 3 times 3, which is equal to 512. For n is equal to 4, a sub 4 is equal to 2 raised to 3 times 4, which is equal to 4096. Lastly, for n is equal to 5, a sub n or a sub 5 is equal to 2 times or raised to 3 times 5, which is equal to 32,768. The finite sequence are 8, 64, 512, 4096, and 32,768. In our next examples, this is the examples of infinite sequence. Example, a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, a sub n, and ellipses. Find the seventh term of a sub n is equal to 2 raised to 2n. To solve this given, let's assign the value of n, which is equal to 7. So a sub 7 is equal to 2 raised to 2 times 7, which is equal to 16,384. Next example is given the sequence a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, a sub n, then ellipses. Find the 10th term of 2n to the 3 minus 2. The solution is, let's assign the value of n which is equal to 10. So a sub 10 is equal to 2 times 10 raised to 3 minus 2, which is equal to 1,998. I hope you like this video. Don't forget to like, share, and subscribe to my channel, Mary TV channel, and also don't forget to click the notification bell down below. Bye! See you next week!